Okay, so we're going to take a look at another question from the 2023 HSC Advanced Maths paper. This is question 26. So we are told a camera films the motion of a swing in a park. Let x of t be the horizontal distance in meters from the camera to the seat of the swing at t seconds. The seat is released from rest at a horizontal distance of 11.2 meters from the camera. We're given the rate of change as a derivative. We're asked to find the expression for x of t. Okay, so we need to find a formula for the horizontal distance. Now, to begin with, we know at t equals 0 at the starting time, we know that x, when evaluated at 0, is equal to 11.2 because the thing starts 11.2 meters away from the camera. So we can take an integral of this. If we take an integral of minus 1.5 pi times sine of 5 pi on 4 times t, integral with respect to t, this will give us the function x of t. Now for that function we'll have a constant of integration, but we will use this initial condition, this t0 x of 0 is 11.2, in order to find that constant of integration. So this is going to be equal to x of t. So now let's just take our integral. Well, this is a negative sign. In order to get a negative sign, we would have had to have started with a positive cosine. So this will be cosine 5 pi on 4 times time. Now the coefficient here is 1.5 times pi. So we could say that that's 6 on 4 pi, or 6 pi on 4. We need to get a 6 pi on 4 out of the chain rule, right? Because to differentiate this, we're going to get a 5 pi on 4 coming out the front, but it needs to become 1.5, which is 6 pi on 4. So there's some constant here, and we have to find this. So let's think about what would happen if we differentiated this. This would become minus 5 pi on 4 times sine of 5 pi on 4 times time. Now this is pretty much the expression up the top, but the 5 pi on 4 needs to be multiplied by something to make it minus 1.5 pi, which is 6 pi on 4. So we need 5 on 4 multiplied by something, which we'll call this n, is equal to 6 pi on 4. The pi's are irrelevant. So if we multiply by 4, this gives us 5 times n equals 6. Divide both by 5. This gives us that n is 6/5. So we need to multiply this term by 6/5. That's the term we will have in front of the original cosine. So we will have 6/5 cosine plus a constant. Now we can immediately check if this is correct by differentiating it. If we differentiate it and simplify it, and it gives us 1.5 pi as is listed above, then it's definitely correct. So let's just quickly do that as a check. So we have 5 pi on 4 from the chain rule times 6 on 5 negative times sine of 5 pi on 4 times time, and the constant would go away. Now this will become 5's cancelling. We've got minus 6 pi on 4, that's minus 1.5, so this is minus 1.5 pi times sine. So this is definitely correct. This is a rather unusual one, right? Getting something like 6/5 when you've got 1.5 is a little bit odd. You can do it a few different ways. The way I've done it here, by finding what the base integral function would be and then differentiating that and then comparing that coefficient to the coefficient in the question, is a good way to find the missing value, but you can do it other ways as well. So now we have this, but we need to evaluate this at t is 0, x is 0 is 11.2. So we have, when we evaluate this, we have x of 0 we know is 11.2, so 11.2 ends up being equal to 6/5 times cosine of 0, because time is 0. Well, this is 1. Cosine of 0 is 1 plus a constant. This tells us 11.2 is equal to 6/5 plus a constant. Now 6/5 is 1.2, so we can minus 1.2 from both sides, and this tells us that C is equal to 10. So therefore, our actual formula, x as a function of t, is equal to 6/5 times cosine of 5 pi on 4 times time plus 10. And this is how we did this question. Now we'll do part B in a separate video so that we don't make these too long, but we'll go through the marking here. Because it's only 2 marks, one of them is going to be for getting the correct answer, the x of t. The first mark is going to be doing something involving antiderivatives or integrations, identifying something special about the initial point, that the t is 0, x of 0 is 11.2, or some equivalent working, right? So we've got a whole heap of working towards getting this solution, and then getting the solution. That will get you the 2 marks.